Hey, what's going on, guys? In this video we are going to talk about Karnaugh map. Karnaugh map is usually called as K-map. Here we are going to see 3 input K-maps. K-maps are used to reduce the expressions. When we have 2 input expression, we don't have to use the K-map. Like we can use the Boolean algebra to reduce the expression, but when we get more complicated expressions like 3 input expression, 4 input expressions, 5, and furthermore we have to use K-map in order to reduce the expression. Otherwise it's going to be really hard doing Boolean algebra. So by K-map it's going to be 10 times easier than Boolean algebra. Now let's look at an example. Let's say we have function of a, b, c, and also the min terms are given, summation of min terms are given by 1, 2, 4, 5, 7. So when they say summation of min term and this one, this is the location where we have ones. Now let's look at the truth table for this one. Okay, let's go ahead and draw the truth table. We are going to have 3 input variables a, b, c. So 3 input variable means 2 power 3. We are going to have 8 different orientations. Now let's see what are they. We are going to have a, b, c, right? So the possible orientations are 0, 0, 0, 0, 1, actually 0, 0, 1, then 0, 1, 0, 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the 8 different orientation we can have in 3 input variables. Okay, now let's look at the positions. This is position 0, 1, 2, 3, 4, 5, 6, 7. And here when they say sum of min terms, these are the positions where we have 1. Now let's look at, first we have 1 at 1, so 1 here, and at 2 we have 1, at 4 we have 1, at 5 we have 1, at 7 we have a 1. Others are going to be 0. This is 0, this is 0, this is 0. Now here we are going to derive the expression of sum of product. Sum of product is min terms. So we have to look at the locations where we have ones. If you look at the location 1, we have a, b, c. A is 0, b is 0, c is 1. So here sum of product mean we have to product all the AND terms. Like first we multiply and then we sum them together each terms. Now if you want to get 1, all of them has to be 1 when we do AND product, right? So if one of them is 0, all of them are going to be 0. So we have to do the not for this one, because we cannot have a 0 in order to get a 1. So we have to have all of them has to be 1 in order to get a 0. I mean in order to get a 1. So we have to turn this 0 into 1. So we have to put a not, b not, and c already 1. So we can keep it as it is. And for the location 2, if you look at this one, here we have 0, 1, 0. A is 0. So we have to turn that one into 1. So we have to put a not. And b is already 1, so we can keep it as it is. C is 0, we have to turn this one into 1, so we have to put c not. And then at location 4 we have 1, 0, 0. So 1 is a is already 1, so we can just keep it as it is. B is 0, c is 0, so we have to not both of them. And if you look at location 5, 1, 0, 1, a is already 1, b is 0, so we have to put a not. C is 1, so we just put c. And then c 7 is 1, so it's already 1, all of them are 1, so we can just directly write it as a, b, c. So now this is the expression for sum of products. Now we are going to use Boolean algebra to simplify this one. Okay, now let's see how to do this. Now if you look at the first 2 terms, oh, you can, this is not good. Let's look at another one. A, b bar, c. If you look at this one is good. Here we have a and a bar. We can take b bar c command. If we take b bar c command, we are going to have a plus a bar. I'm combining these two together. So whenever we have a and the complement of it, if one of them is 0, other one is going to be 1. If this is 1, this is going to be 0. So if if we have 1, 1 in OR gate, that's going to be definitely 1, right? So here anyway we are going to have 1 because we have a and a not. So if one of them is 0, other one is going to be 1. If this is 0, this is going to be 1. So we are going to have 1 anyway. So this is mean we are going to multiply this one by 1. So the final result is going to be b bar c, and others are going to remain the same. We are going to have a bar b c bar plus a b bar c bar, and then we combine these two together already and simplified, and the final one remains the same, a b c. Now I could have done one more thing, like whenever we have OR gate, and if we have a, we can add this one as many times as you want, because if this is 1, the final result is going to be 1, right? If a is 1, 1, 1, 1, that's going to be 1. If this is 0, that's going to be 0. So you can add this one as many times as you want, so it's not going to change the results. So what we can do is, we can add this a b bar c again. So let's write this one, it's a different color. We are adding this one again. So this one is going to help us to simplify this one furthermore. Here you can see we have AC common, AC common. So b plus b bar, like we did before. So this is going to be what we are going to have, AC common, b plus b bar. So that's going to simplify this one into AC, because if one of them is 1, other one is going to be 0. If this is 0, the other one is going to be 1. So we are going to have any, like just if we have 1 1 in OR gate, this is going to be 1. So AC multiplied by 1, that's going to be AC, right? So finally we will get b bar c plus a bar b c bar plus a b bar c bar plus AC. Okay, now we simplify this one like this. Now let's see whether we can simplify this one furthermore. Now here we have b bar. If we take b bar, like if you look at these two right here, if we take b bar common, this is going to be what, c plus c bar a. This one will be simplified into b bar c plus a. So there's a Boolean algebra equation says when we have something like this, it can be simplified as b bar c plus a. So finally we will get b bar c plus a b bar, because we are multiplying these two together. So b bar c, a b bar, and the others are going to remain the same. We have a b c bar, actually a bar b c bar, and the final one is AC. So as long as I can see, this is the maximum possibility of simplification. But we can do the same thing with K-map 10 times easier. Now let's look at the K-map. Okay, let's keep the final result right here, because we are going to compare. I get rid of this one and do the K-map. Okay, let's get rid of all of these things. For the same given min terms, we are going to do the K-map. Okay, before we go and directly plug the K-map, now let's look at the location of K-map. Let's erase this one too. Okay, so let's go ahead and draw a K-map. So since we have 3 input variables, we have to have 8 boxes, because 2 power 3, 8. So we are going to have 8 boxes. Okay, and then let's say this is 1 box, 2 box, 3. Then we divide this one into 2. We have 3 variables, a, b, c. So we can put a, b like this and c like this. Okay, and then we have to divide this one by numbers. The first number is going to be 0 0 0 1 1 1 1 0. So this order always follows as it is, and this one will be 0 1. Now if you look at this one, we have to always start from a, b, c, right? 0 0 0 0 0 0. We are looking at the locations. Now let's write this one a little bit smaller. Okay, so let's look at the location. So 0 0 0, this is, we have to look a, b, c, right? A, b, c is the order. So 0 1 0 0 1 0. Then here we have 0, actually 1 1 0 and 1 0 0, and this one is what, 0 0 1. This one is 0 1 1, and this one is 1 1 1. This one is 1 0 1. So I put the 2 numbers on top first, and this one's after that, right? So here you can see 0 0 0 0 1 0 1 1 0 1 0 0, then 0 0 1 0 1 1, and we know that when we have these 3 numbers, that goes like 8 4, actually 1 2 4. Okay, so 4 2 1, it goes like that. And if you look at this one, this is location 0, and this is location 4 2 1. So this is location 2, and this one is location 6, and this one is location 4, and this one is location 1, and this one is location 2 plus 1 3. This one is location 7, and this one is location 101, that's going to be 5. So this is the locations we are going to have. So because we need this one, because we need to know the locations. Okay, now we are going to draw the K map for our problem. This is our problem. Now this is just to illustrate the locations. Okay, now we are going to directly put the locations in our K map and find the final answer. Okay, let's draw our K map. Okay, so here we are going to have 8 boxes again. Okay, so let's go ahead and plug the numbers A, B, C. So this is 0 0 0 1 1 1 1 0 0 1. I write the location in small small. This is going to be 0 1 2 3, and this is 6 7 4 5. Now we have to we have the summation of minterm 1 2 4 5 7. So these are the locations we are going to have 1. Now let's look at the locations. Okay, let's put it with a different color. So location 1 we have 1. Location 1 is this one, right? So this is 1. And location 2 we have 1. Location 2 we have 1. Location 4 we have a 1. Here we have 1. Location 5 we have a 1. Location 7 we have a 1. Others are going to be 0. So this one is 0, and this one also going to be 0. Okay, and also this one is 0. Now when we do the K map, we have to look at the way where we can combine in this way. Like we can combine 1, like if it's just 1 alone and we cannot combine with any other things, we can just keep it as 1. Otherwise we have to combine 2 4 8 16, and the higher number is better. 16 is better than 8, 8 is better than 4, 4 is better than 2, and 2 is better than 1, right? So we have to always look at the higher number possible. Now the ways we can combine is we have to combine next to each other, or if we have one in the bottom and top, we can combine like this or together, like it depends on the situation. Now let's look at this one. Here we have 2, we don't have any 4, right? We don't have any possibility to combine 4, so we have to look at the next small value possible, that is 2. Next maximum value possible, that's 2. So we can combine these 2 together. Okay, and also we can combine these 2 together. And there's another way. When we have something in the corner and this corner, we can combine that one too. So we can combine like this corner and this one, because if you like think it like folding, it's like it's adjacent to other one, right? So we can combine these 2 together, and this one is left alone. We cannot combine with anyone because we have to have another one next to it and the bottom of this one. That's the only way. We cannot connect corners, so we have to just left this one alone and find the expression. Now we have to look at the only variable that's changing. Okay, now let's look at the this one, or let's start with this one to clarify this concept. Here the first term is for A, the second term is for B, and this one is C, right? This one is C. And if you look at this one right here, the first one we did, that is in this one, you can see, okay, it's better to do this one individually, otherwise we are going to be complicated and we don't know what we are doing, right? So I'm going to do this one again individually, like I'm going to find the expression and draw the next one. In that way we don't get complicated, like we don't get confused. Okay, now let's start with this one. So I combine these two together. Okay, if I combine these two together, let's see what's the expression we are going to have. Here the first term is for A, second term is for B, and this y side is for C. Okay, here you can see A is, if we have to just look at these two terms. A is not changing, B is changing. So if it's something is changing, we don't have to worry about that one. We have to look at the one that's not changing. So A is not changing, so we are going to have A, right? A is 1. If A is 0, we have to put a complement. If it's 1, we can just leave it as it is. But since we are dealing with small abc, it's better to write small. Okay, small a. And then if you look at this C, C is not changing for this line. So we can put C also. So we just have to see what is not changing. And then if you look at this one, for this one, what is this one? A, B are not changing. So A, we can keep it as it is, but B is 0. So we have to put a complement. And if you look at C, C has 0 and 1. So C is changing. We cannot write that one. We have to just keep it as it is. And let's look at this one. We looked another one that is from this corner to this corner. Because these are adjacent. If you like think like folding together, these are next to each other. So we can combine these two together too. Or if we have, so let's look at this. So okay, this is for this one. Or if you have 4 K, like if you have some extra K-map tables, and if you have something in bottom one and top one, we can also connect that one like that, because like we can think it like folding it vertically. But let's look at this one first. Okay, here we have A, B. A is 0, B is 0. Here A is 1, B is 0. B is not changing because B is remaining 0 in both of the case, but A is changing. A is becoming 0, 1. So we have to just look at the terms that's not changing. Since B is not changing, we are going to have B, but B is 0. So we have to turn this one into 1. So B bar. Then if you look at C, C is also not changing. C is 1 right here, and here also C is 1 because this side is 1. So this is not changing. So we just have to put C right here. And C is already 1. We don't have to put a complement. Okay. And this one is left alone because we don't have anything next to this one, or we don't have anything bottom of this one. So we have to just write this one alone. And for this one, since we don't have anything else, for this one nothing is changing. Everything is as it is. Like A, B remains the same 0, 1, and C remains the same 0. So A is 0, so we have to put a complement A bar, and B is already 1, so we can just keep it as it is. C is 0. So we have to put a complement. Now let's compare the answers. AC, AC. This one we got from Boolean algebra expression. So this one we got from K-map. AC, AC. And then we have A, B bar here, A, B bar here. And B bar C, B bar C, B bar C. And then here we have A bar, B, C bar. A bar, B, C bar. So you can see this is much simpler than this one. For this one, you had to, sometimes you might make mistake too, like you cannot see things. But for this one, this is much simpler and easier. Now let's look at another example. Let's say we have, let's get rid of all of these things first. Okay, let's look at another example. Let's say we have a function of sum of product like x plus y c bar plus x bar z. Okay, here we have sum of product. So this is, we have to look at the locations where we can get one. Now since we have 3 variables x, y, z bar, we are going to have 8 box K-map. Now let's go ahead and draw the K-map. Okay. Okay, so this location is going to be, this is 0 0 0 1 1 1 1 0, and this one is xy. We can take this one as xy, and this one is z. This is 0 1. Okay, now first one, for this one to be 1, right? For this one to be 1, this has to be 1, or this has to be 1, or this has to be 1. If any of them is 1, the whole thing is going to be 1. So when they give sum of product, it's basically we had to look at the possibilities of getting 1. So for x to be 1, we had to have, so okay, let's write this one with a different color to see this one clearly. X, Y, Z. So for x to be 1, I mean for this one to be 1, x, if x1, the whole thing is going to be 1. Now let's look at the positions. We have x is equal to 1. The first term has to be 1. X is the first term of this one. The top part, the x is the first term. Now if you look at the first one, 0, 0, but for this one x is 1. So here we are going to have 1. For this one we are going to have 1. This one also x is equal to 1. This one also 1. So these are the positions we are going to have 1. Now y z bar. In AND product, both of them has to be 1 in order to get a 1. So y has to be 1 and z has to be 0, because this z complement, if z is 0, this is going to turn into 1. So we have to have y is 1, z is 0. So second term is y in the top. So y has to be 0. This position y is 0, this position y is 0. And also we have to have z is 0. So z is 0 in this position. Okay, y has to be 1 and z has to be 0. So this is 1. And others are already taken, so we don't have to worry about that one, right? And then we have to have x is 0 and c has to be 1. So if x is 0, then it's going to turn into 1 because x complement. So x has to be 0 and c has to be 1. X is 0 in first one, second one, and z is 1 only in this one and this one. So these two are going to be 1. Okay, and whatever else left, that's going to be 0. So this is the only box that's left. This is going to be 0. Okay, now let's see how we can derive sum of product and product of sum. For sum of product, we have to look at the position where we have 1, and we have to combine like 2, 4, 8, 16, right? 16 is better than 8, 8 is better than 4, 4 is better than 2, and if we don't have 2 and 1 is alone, we just have to take 1 alone. Okay, now let's look at the possibilities of getting 8. We don't have any possibility of getting 8 because we only have 8 and 1 is 0, so we don't have possibility of getting 8, but we have possibility of getting 4s. So we can combine these 4 ones together, and also we can combine these 4, we can overlap, like as long as it's not fully taken, we can combine. So we can combine these 4 together. Since we have 1 left around, we can also combine these 4 together. Okay, now let's look at this white one. So for the white one, what is not changing? Here you can see x, y. X is going from 0, 0, 1, 1. So x is changing. Y is 0, 1, 1, 0. Y is also changing. But z is just 1, always 1. So z is not changing. So that's the one we have to put z alone. For the red one, let's look at the one that's not changing. X is changing. X is going from 0, 1. So x is changing. Y is not changing. Y is 1, 1. So y is not changing. We can put y. Z is also changing. Z is going from 0, 1. So Z is changing. So we don't have to put that one. Now let's do the yellow one. Yellow one, we have x is not changing because 1, 1. Y is changing, 1, 0. So x is not changing. Put x. And y is changing. We cannot put that one. Z is also changing. Z is going from 0, 1. So z is also changing. So this is going to be the final result. Z, y, x. So this is our sum of product. Now if they ask for product of sum, we have to look at the locations where we have 0. Since we have only 1, 0, for this 0, nothing is changing. Everything is as it, like we have only one position, so all of them are 0. So we can just directly write x plus y plus z. So this is going to be product of sum. Okay, now let's look at another example. Let's say we have a function. Okay, let's say we have a function given like this: f a b c, and summation of min terms 1, 2, 3, 1, 2, 3, and then 6, 7. Okay, so here we have summation of min terms. We are going to create the k map. Since we have 3 input variables, we are going to have 8 boxes. Now let's go ahead and create the boxes. Okay, here we are going to have something like this. 1, 2, okay, 8 boxes. Okay, and here we have 3 input variables. Those are A, B, C. Okay, now let's look at the locations. This 0, 0, 0, 1, 1, 1, 1, 0. This is 0, 1. Okay, so let's put the location in small letter, because this is dependent on location. The first one is 0 location, and then this one is 1, this is 2, this is 3, this is 6, this is 7, this is 4, this is 5. So when they give summation of min terms and they give this one, this is location of the ones. Okay, at 1 we have 1, so this is location 1, we have 1. At 2 we have 1, 2 is this one, this we have 1. At 3 we have 1, here this is 3, we have 1. 6 we have 1, 7 we have 1, others are going to be 0. Okay, now let's go ahead and find the sum of product. Sum of product, we had to look at the possibility of getting 2, 4, 8, 16. 16 is better than 8, 8 is better than 4, 4 is better than 2, and 2 is better than 1. Now let's see whether we have 8. 8 is not possible because we don't have any possibility. Now 4 is possible. If you look at this one, this is making 4, so 4 is possible. Okay, so 4 is possible for this one. And also we have this one is left alone, but we can combine these two. Let's draw with a different color. We can combine these two. Okay, now let's go ahead and write the expression for this one. So first one, we had to look at the things that's not changing. 0, A is changing, 0, 1, A is changing, B is not changing, B is 1, 1, so B is going to be one of the answer. And then C is changing, so we cannot write C. Since we have the question is given in small, let's write it in small. So this is B. And then if you look at this one, this 2, we have A, B. A is changing, but we have to have this one in 1, but this is 0, so we have to put a bar. And then C is not changing, so we can put C also, but B is changing. B is going from 0, 1, so B is changing, we cannot put that one. So this is going to be sum of product. Sum of product, and also called min terms. Min terms. Now let's look at the zeros, max terms, or we can say product of sum. So here we have 0. Let's try to combine these things. So 4 is not possible because we only have 3 zeros. So we can combine 2 like this, and also we can combine these two also. When we have 0 in the corners like this, these are adjacent. It means we can combine these two, right? Now let's look at the rose color one. Okay, let's write with a different color. Now for the rose color one, which one is changing? A, B is remaining the same because this is vertical, so this is not changing. So A is 1, but this has to be 0. When we do the product of sum, we had to make everything into 0. So A has to be complemented. So A complement, and then B is already 0, so we can just keep it as it is. So A plus B, right? So when we do the product of sum, we have to put plus, but when we do the sum of product, we have to multiply. Okay, that's the difference. Now the next one, we have to multiply the whole thing together. So this one is, we are looking at this rate. If you look at A, B, A is 1, 0, so A is changing. B is 0, 0, B is remaining the same, so we can put B. And then C is not changing, C is 0, and here also 0. So C is also not changing, and that's already 0, so this is going to be just B plus C. This is going to be our product of sum, or we can call max terms. Okay, Now let's look at another example. So this is like when we do K-map, there's no only one answer. Like you can have different way of doing things. Now here we are going to look at an example where we can have two different answers, but both of them are correct. Okay. Now let's go ahead and write the expression for this one. Let's say we have a function h, a, b, c, and they have given the summation of min terms. That's given by 0, 1, 2, 5, 6, 7. So these are the locations where we have ones. Now let's go ahead and draw the K-map. So since we have three variables, we are going to have an 8-box K-map. Okay, so we are going to have a K-map like this. Okay, so the variables are a, b, c. We are going to have a, b, and also c. Now let's put the numbers. This is 0, 0, 0, 1, 1, 1, 1, 0, and here we're going to have 0, 1. Okay, now the first one. Now let's put the locations first. This is 0 location, this is 1 location, this is 2, this is 3, and this one is 6, this one is 7, and this one is 4, and this one is 5. And let's also draw another K-map because we are going to do this one in a two different way. Okay, let's go and draw another K-map. Okay, here we have a, b, and here c. This is 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, and the location is 0, 1, 2, 3, and then 6, 7, and then 4, 5. Now let's look at the locations where we have 1. At 0 we have 1, 0 we have 1, at 1 we have 1, 1 we have 1, at 2 we have 1, at 2 we have 1, at 5 we have 1, 5 is this location, we have 1, 6 we have 1, and also 7 we have 1, and others are going to be 0. These two are 0, these two are 0. Now let's look at the one possible way. So we have to look at the position where we can have 8, 4, like 16, 8, 4, 2, 0, actually 1. 16 is better than 8, 8 is better than 4, 4 is better than 2, 2 is better than 1. Okay, here we don't have 4. So let's look at the possibilities of getting 2. We cannot connect 3, like it has to go like 2, 4, 8, 16. Now the next possibility is getting 2. So let's look at the possibility of getting 2. This is one of the possible 2. And also we can connect these two together, and this also connect these two together. So one, all of them are taken, we cannot do again, like one souls are gone, that's it. Now let's look at the first one. First one we have AB. AB is not changing, and we are looking at the sum of products, so we have to make this one into 1. So this is A, B, both of them are 0, so we have to put A bar, B bar. And if you look at C, C is changing, so we cannot put that one. And for the second one, here C, A is 0, B is, like A is changing, right? 0, 1. B is not changing, so we can write B. C is also not changing, that's 0, so we have to put a complement, C complement. And let's look at the next one. Here we have A, 1, 1. A is not changing, so we can put A. And B is changing, 1, 0, B is changing. C is not changing, so we can put C. So this is one of the possible way. Now let's look at another possible way to do this one. Okay, now we have to look at another way we can connect 2 in a different way. Like here we can connect 1, 1 like this. Previously we didn't do like this. You can see we connected vertically, but here we have horizontally. And then we can connect these two 1. And then we can connect this one with the other corner. Okay, you can think it like folding it together, because this is adjacent, so when you fold it's going to connect next to each other. So this is one of the another possible way to do this one. Now let's look at the first one. First one we have A is not changing, so we can put A bar because A is 0, so we can put A bar. B is changing, we cannot put this one. C is not changing, that's 0, so we have to put a C complement. Okay, now let's look at the second one. Here we have A, B, both of them are 1, so we can put, and that's not changing, so we can put both. C is changing, so we cannot put that one. And if you look at the last one here, this corner and the other corner, A, B is 0, 1, A is changing, B is not changing, 0, 0, so B, we can put B, and that has to be complemented because it's 0, so we have to change this one into 1, so B bar. And then C is not changing, that's already 1, so we can keep it as it is. So this is another possible way, and if you compare the answers, those are different, but these two are correct, right? A bar B bar plus B C bar plus AB, but here we have A bar C bar plus AB B bar C, and that's how we do the 3 input K maps. I hope this helps. Thanks for watching.